Hi, I'm Sam Brown.
Hi, I'm Damien.
Hi, I'm Mike.
And this is our project.
For our project, we needed to build an RFID interface which, once detected, would bring up a video on screen.
Cool. This is our cube. It has 6 sides like a normal cube does. In each side there is RFID tag which contains a unique code. The detector detects the code and then displays a video on the screen. Cube.
This is the detector, built like a tower with the RFID antenna here. The RFID antenna will detect the cube, send the data through this cable to the computer. This is the LED. When a cube is detected, it will light up.
Our code. We start off with the normal Flash package up here, and then we import all of our phidget resources here. Next one, we import all of the other Flash resources, so we have things for keyboards, sprites, stage quality, text field, movie clips, which are very important for this, the timers, your video, and your net connection and net stream, which allows us to stream video. The next thing we import is a custom class called keypole. This was used for testing, just for some keyboard commands so we could have a look around our virtual environment. Next we import the Papervision resources, which allows us to use the Papervision 3D engine. We have things for movie materials, camera types, because we're using a spring camera. Spring camera is defined here. And then we have Collider, which allows us to import 3D models from the outside world. Our program begins here. We define our objects, such as the skybox, which is a cube, and all of our planes, which all of our movies are played on. We then have a materials list, which allows us to show the images on the planes. Next, we define the variables. We have a start time, which is used for calculating the frames per second, or FPS. This is displayed in the top left of the program when running. The tag value is the value which is contained within the RFID. Each RFID has a unique tag value, and this plays a unique movie for each tag. This section here is all the variables for the frames per second again. We then define our custom classes again, and this is the end of variables. Next we go into defining the connections and the streaming for the video, so that's this bit here. And now we are on to the main program. This section here contains all the properties of how the stage should be displayed. We have a frame rate maximum of 40 frames per second. We then also define all of our event listeners for attaching and detaching the phidget module, but also detecting the RFID tags and detecting the loss of them. Here we define the local host and the port that we're going to be using, and then we go into a function called init and one called start rendering. The init function here defines the spring camera, so So we have a mass of 7, damping of 6 and a stiffness of 3, which allows the camera to slightly bounce around, giving it quite a cool effect. We also call our other functions here, such as display FPS, make skybox and make planes. The make planes function creates 6 planes in the virtual environment. Each one has its own video stream material, apart from plane number 4, which contains an image of instructions for the program. For planes 1, 2, 3, 5 and 6, the material is animated, which allows for the video to be played. All of the planes are double-sided, which allows the image or video to be displayed on both sides of the plane instead of just one side. This section here just defines the plane values about where it should be located in a 3D environment, how large it should be, and how many segments should make it up. These functions here detect errors when with the fidgets. The on attach tells us if the fidget has been correctly attached to the program. The on detach is an event to do when the fidget has been lost. The next event is the on tag event. This does certain things when an RFID is detected. So here we have a switch statement which contains a case for every single RFID disc that we have. The unique number inside the RFID is defined here. When this disc here is attached, we move the camera to target plane 1. We then play the video and then start the stream. This happens 6 times for 5 different videos and the instructions. We also have the detection here for the cards and the key fobs, but we will not be using those in this project. We then have a function here for on tag loss. This stops the video from playing when a tag has been lost. It also moves the camera's view back to the instructions so that a new tag can be detected. This is the function for displaying the frames per second. It just uses some simple calculations to display the number of frames being displayed. This function here is the make skybox function. A skybox is essentially a big cube that our 3D world is contained within. It's all stitched together to make it look like an endless space instead of just a cube from the inside. And here at the bottom we have some key controls for looking around our 3D environment for testing. These won't be included in our final version.
As you can see on the screen, this is the home page. Once you take the cube out and change the side, obviously it'll change the video selection depending on what side of the cube it's facing. And once the cube's removed, it goes back to the home page.
Setting up the fidget. To set up the RFID fidget, simply visit the fidget website where you will be able to download the drivers for your fidget. As you can see here is our RFID fidget attached to the laptop. If you double click this item, you will get properties related to the fidget. This will allow us to change any settings that we need to. Under the Web Service tab, we can set a server ID and port. In this case, it is set to localhost as we are running the RFID application locally. We have to start a web service to allow our application to communicate with the fidget. Under Bonjour, we can see now our fidget is attached to a server and is running. This is now ready to use
for our application.
No, it just went.
Hi, I'm Mike. Hi, I'm Mike.
It's all blurry.
And this is our project.
We need to look at
And you know